Tonight, we're going to talk about the most misunderstood argument in modern philosophy, and about why almost everybody who repeats it gets the frightening part wrong. The popular version is that we might be living inside a simulation. That is not the argument. It is 1/3 of it, and it is the least disturbing third. The actual claim, made by a philosopher at Oxford in 2003, is that at least one of 3 statements has to be true. Not that any particular one is true, that the 3 of them cannot all be false at once. Here they are, in plain words. Almost every civilization that reaches roughly where we are now dies before it becomes capable of doing anything much larger. Or, almost every civilization that does survive to that point chooses never to recreate its own past, and keeps choosing that, everywhere, forever. Or we are almost certainly not real. You do not get to pick which one. That is what makes it an argument rather than a suggestion. If you want to reject the third, you are obliged to accept one of the first 2, and both of those are grim in their own way. The first one in particular is not a philosophical curiosity. It says that nearly everything that ever gets as far as we have got is already gone. By the end, you'll know what the 3 options actually are, why the first one is the one nobody talks about, and why somebody worked out a way to test all of it using the highest energy particles that reach this planet. Tonight comes in pieces, and each one stands on its own. If you drift off partway through, nothing later depends on what you missed. Start with the man and the paper, because the misreporting began almost immediately. His name is Nick Bostrom, and in 2003 he published a short paper in a philosophy journal with a plain title. It asked whether we are living in a computer simulation. The paper is not long, and it is not difficult, and its central move is a piece of counting rather than any claim about technology. It runs like this. Take a civilization that survives long enough to build very large amounts of computing power. Not magic, just a great deal of it, more than we have, on a scale that does not obviously break any physical law. Some of that capacity might get spent recreating the past, running detailed versions of earlier eras, populated by minds that experience those eras from the inside. That is not a strange thing to want. We already do a smaller version of it constantly. There are people whose entire working lives are spent reconstructing what a particular street looked like in a particular decade, or how a battle actually unfolded, or what somebody ate in the year 1200. History is an enormous ongoing effort to recover the texture of moments that are gone. A civilization with vastly more capacity would presumably still want to know, and the more capacity it had, the more detailed the recovering could get. If any civilization anywhere ever does that, even occasionally, then the number of minds who believe they are living through an original era is vastly larger than the number who actually are, because the original happens once, and the recreations can happen any number of times. And if the recreated minds hugely outnumber the original ones, then any given mind, chosen at random, is far more likely to be one of the many than one of the few. That is the whole engine. It is not a claim about what is technologically possible, it is a claim about what follows if it ever is. One thing first, if you want more nights like this, subscribe, that's all I'll ask. Back to it. It is worth saying who wrote it, because the reception tells you something. Bostrom is a philosopher who has spent most of his career on questions about the long-term future, and for nearly 20 years he ran an institute at Oxford dedicated to them. His work is mostly about risk, about the ways a species can end, and about how to think clearly regarding things that have never happened. The simulation paper is a small part of that output, and it is the only part most people have heard of. He has written far more about extinction than about recreations, which is the joke buried in all of this, because the first of his 3 options is an extinction claim, and it is the one nobody quotes. The paper itself is short. It ran in a philosophy journal in 2003. It is freely available, and anybody can read it in an afternoon. It contains no equations more difficult than multiplication. That accessibility is part of why it escaped into the culture. It is also why it has been mangled. A short readable paper is easy to summarize badly, and the bad summary is the one that spreads. Now the part that gets lost, and it is the reason this video exists. Bostrom did not conclude that we are in a simulation. He has said so repeatedly, in print, for over 20 years, and it has made almost no difference to how the argument gets repeated. What he concluded is that the three statements cannot all be false. If you are confident that we are real, then you are committed to believing that either almost everything dies before it gets big, or that everything which survives universally refuses to look back. There is no fourth door. That structure is what makes the argument hard to dismiss. It does not ask you to accept anything strange. It asks you to notice that the ordinary, comfortable picture where civilizations survive and grow and eventually do interesting things with their capabilities, and where we are nonetheless real, requires a very specific and very unlikely set of conditions. Which brings up an objection that people raise immediately, and it is a good one, so it belongs here rather than buried at the end. The counting only works if a recreated mind experiences anything at all. That is not established. Nobody knows what produces experience, or whether a sufficiently detailed process running on something other than biology would have any. It is one of the genuinely open questions, and it is not close to settled. Bostrom's paper assumes it can happen. If that assumption is wrong, the argument does not get off the ground. So the honest framing is that the trilemma follows from a premise most people find plausible and nobody has demonstrated. That is worth knowing before anything else, and I would rather put it in front of you now than let it arrive as a gotcha 2 hours in. It is worth checking that the structure is doing what I say it does, because arguments of this shape can be built badly, and this one is not. The form is old, and it is used constantly outside philosophy. You take a set of statements, show they cannot all be false together, and hand somebody the job of deciding which to keep. A detective does it. If the door was locked, and nobody had a key, and nothing was forced, then one of those three is wrong. That is not a claim about which. It is a demonstration that the comfortable account does not hold. What makes tonight's version bite is that all three of its options are things people would rather not believe. Most arguments of this shape have at least one comfortable branch, and everybody quietly takes it and stops thinking. Here there is no such branch. Whichever you choose, you have accepted something you did not want. That is unusual, and it is the reason the paper is still discussed 23 years later, when a great many cleverer philosophical arguments from the same period are not. There is a second thing worth clearing up, because it changes what kind of claim this is. None of this is about anybody's motives. There is no suggestion that somebody built this deliberately to observe us, or that there is a purpose, or a plan, or anybody paying attention. The recreations in the argument are not experiments on us. They would be something closer to a very detailed historical record that happens to be run rather than read. Nobody in the argument is watching you. That is not part of it, and it never was. I mention this because the popular version drifts toward a story about being observed, and being observed is a much more comfortable idea than the alternative, which is that a process is running and nothing in it is aimed at anybody. So set aside the version you have heard. The claim on the table tonight is narrower and stranger. 3 statements, at least one true, and the first of them says that nearly everything that ever got this far is already gone. The first of the 3 options is that almost nothing survives long enough to matter, and it is the one that gets skipped in every retelling I have ever seen. Stated properly, it says that the overwhelming majority of civilizations that reach roughly our level are destroyed, or collapse, or otherwise stop before they ever become capable of anything much larger than what we can do now. Not some of them. Nearly all of them, as a rule, reliably everywhere. That is not a claim about simulations at all. It is a claim about death, and it is the same claim that comes out of the silence in the sky when you point instruments at other stars and nothing ever answers. Which is the thing worth noticing about this whole argument. 2 completely separate lines of reasoning, starting from completely different places, arrive at the same uncomfortable first option. One starts with the emptiness of the sky and asks why nobody is out there. The other starts with a counting problem about minds and asks what has to be true for us to be real. Both of them land on the possibility that almost everything dies before it gets big. When 2 arguments built from different materials point at the same conclusion, that conclusion deserves more weight than either would carry alone. It is worth being concrete about what much larger means, because the argument needs a threshold, and the threshold is enormous. In 1964, a Soviet astronomer named Nikolai Kardashev proposed a way of ranking civilizations that had nothing to do with their culture or their knowledge. He ranked them by energy. The first rung is a civilization using all the energy available on its own world. The second is one using all the energy of its star. The third is one using the energy of its entire galaxy. We are not on the scale. Estimates put us somewhere around 7/10 of the way to the first rung, and the first rung is the smallest one. To run detailed recreations of a past era, populated by minds, the argument needs something at least at the second rung, not a bigger version of us, something that has the output of an entire star at its disposal and can direct it. That is the threshold in question, and nothing on this world is remotely close. So the first option is not saying that most civilizations have a hard time. It is saying that the distance between where we are and the second rung is a distance almost nothing covers, and that almost everything trying stops somewhere along it. We are 7/10 of the way to the first of 3 rungs, and the argument is about whether anybody ever reaches the second. Now, what dying before you get big would actually mean, because the phrase is doing a lot of work. The threshold in the argument is not survival in a general sense. Plenty of things survive. It is reaching the point of being able to do something on an enormous scale, which requires an unbroken run of a very long time. We have been technological for roughly a century, industrial for about 250 years. The threshold in question is presumably thousands of years further on, at minimum, possibly far more. So the first option says that essentially nothing makes it from where we are to there, that the stretch between inventing radio and becoming genuinely capable is a stretch almost nobody crosses. We are inside that stretch right now. That is the whole reason the option is not academic. The obvious question is, what would stop everybody? And the honest answer is that nobody knows, and that the candidates are all speculation. The usual list is short. Weapons capable of ending everything. Damage to a planet's systems faster than the ability to repair it. Engineered organisms. Machines that get away from the people who built them, or something nobody has thought of, which is probably the category that deserves the most concern, because we are the only example available, and we have been at this for about 100 years. Notice what every item on that list has in common. There is no evidence for any of them. Not one has ever been observed happening to anybody. They are all inferred from absence, which means the reasoning runs in a circle. Nothing is out there, so something must stop everybody, and we know something stops everybody because nothing is out there. That circularity does not make the first option false. It makes it unsupported, which is a different thing and worth being precise about. You will run into that circle constantly once you can see it, and not only in this subject. An absence gets explained by a mechanism, and the mechanism gets its only support from the absence, and the two hold each other up with nothing underneath. The test is simple. Ask what evidence there would be for the mechanism if the absence were explained some other way. If the answer is none, then you have one fact wearing 2 hats. There is a version of this that is less dramatic and considerably more likely, and it deserves the airtime. Nothing has to destroy a civilization for it to fail to get big. It could simply be that the enormous capability the argument requires is not reachable, that there is a ceiling nobody crosses, not because they die, but because the physics does not allow what the argument assumes. Building computation on the scale required needs energy, and energy on that scale needs infrastructure, and infrastructure on that scale needs the ability to operate across enormous distances for enormous stretches of time. Every one of those has hard limits that nobody has shown how to get past. So a civilization could last for 100,000 years, stay home, be perfectly content, and never come anywhere near the threshold this argument is about. It would count as failing the first option without anything bad happening to it at all. That is a real possibility, and it is the least discussed version of the first horn. There is something worth doing with that first option before moving on, and it takes a moment. You have almost certainly assumed at some point that things generally continue, that there will be people in 1,000 years doing things in a world that came from this one. Most people carry that assumption without ever having examined it, because there has never been much reason to. The first option says that assumption is the unusual case rather than the default one. You are not obliged to believe that. I do not particularly believe it myself, but it is worth noticing that you hold the opposite, that you have never checked it, and that the checking is not available. Nobody knows what the survival rate is for civilizations at this stage, because nobody has ever seen a second one. You are inside the only example anybody has, which is a poor position for working out the odds, and the only position available. Now the second option, which sounds like the easiest one to accept, and turns out to be the hardest. It says that civilizations do survive, and do become enormously capable, and then essentially none of them ever recreates its own past in any detail. Not most of them. Essentially all of them, without exception, forever. The reason that is hard is the size of the claim. It is not asking whether a particular civilization would find this interesting. It is asking whether every single one that ever exists, across whatever number of them there are, across however long the universe permits, all independently decide not to. Uniformity like that is rare in anything. Get a large enough population of anything and you get outliers. The second option requires there to be none. There are reasons somebody might decline, and they are worth taking seriously rather than dismissing. One is ethical, and it is much stronger than it gets credit for, so it deserves proper time. Recreating a past era in enough detail to contain minds that experience it means those minds experience whatever that era contained. Think about what any actual era has contained. Every disease anybody has ever died of, every famine, every war, every child who did not survive their first year, in the centuries when most of them did not, all of it occurring in full to minds that experience it as it happens. And not only the large catastrophes, which is the part that gets missed, every ordinary bad afternoon anybody has ever had, every argument, every loss, every long illness, every person who spent decades unhappy for reasons nobody recorded. You have had days you would not choose to live again. Everybody has. Under this arrangement, somebody would be choosing them, for you, knowing what they contained. The recreations would not be highlights, they would be everything, because a recreation that leaves out the difficult parts is not a recreation of anything and would tell nobody anything. A civilization capable of running these would not be recreating a documentary. It would be producing the thing itself, including all of the parts nobody would choose, and it would be doing it deliberately, knowing in advance exactly what the era contained, because it has the records. There is no ignorance available as an excuse. That is a genuinely serious objection, and it is not a squeamish one. It is the observation that this activity, if the minds inside are experiencing anything, is the deliberate mass production of suffering that has already happened once and did not need to happen again. A civilization that thought about it clearly might well conclude that it is among the worst things anybody could do, and forbid it absolutely. There is a version of that objection that is sharper still. The ones running it would know the outcome. Every death in the recreated era is a death they could have prevented by not starting, and they started anyway, with full knowledge, for the sake of finding something out. No research ethics anybody has ever written would permit that. The standards that govern experiments on people in this era would forbid it several times over, and those standards exist because of things that were done before anybody wrote them down. So the second option has a strong case behind it. It is not merely that nobody bothers, it is that anybody thoughtful enough to be capable might be thoughtful enough to refuse. And here is the difficulty with resting on that. It requires the refusal to be universal. Every civilization, everywhere, for however long any of them last, arriving independently at the same conclusion and holding to it without exception. You already know how well that works, because you have watched it fail your whole life. Every rule your own society has agreed is important is broken somewhere by somebody, continuously. The ones that hold best are not the ones everybody agrees with. They are the ones where breaking them is difficult, or expensive, or easily noticed. We are not able to manage that within a single species over a single century, on questions considerably easier than this one. Every rule anybody has ever written has been broken by somebody, and the rules that hold best are the ones where breaking them is difficult, rather than merely forbidden. For a civilization at the scale the argument requires, running one of these would presumably not be difficult. It would be cheap, and things that are cheap and forbidden get done quietly. So the ethical case is strong for why most would refuse, and weak for why all of them would, forever without a single lapse anywhere. That gap is exactly the size of the third option. There is a version of the ethical objection that points the other way, and it is worth having because it is the one people find hardest. If the recreations are ethically monstrous, then whoever is running the one we might be in is doing something monstrous, and knows it. Which means the third option, taken seriously, does not describe a benign arrangement with somebody kindly maintaining a world. It describes something being done to a very large number of minds by somebody who has the records and started anyway. That is a considerably darker reading than the one in circulation, where the idea usually arrives with a faint suggestion of purpose or care, as though being inside one would mean somebody had reasons. Nothing in the argument supplies reasons. The most likely motive, if there is one at all, is curiosity, which is not a motive that has ever protected anybody, and there is a possibility that is bleaker still and entirely consistent with everything above. Nobody may be paying attention. Something can run without being watched. A recreation started for one purpose could carry on long after anybody stopped looking at the output. In the same way, a great deal of what runs on this world runs unattended. So the range of possibilities inside the third option runs from somebody carefully studying an era to a process nobody has checked in a very long time, and the argument gives no way to prefer either. Another is that they might simply lose interest. There is no law saying a very old civilization stays curious about its own beginnings. It might find the question as uninteresting as most people find the details of their great-grandparents' lives. Another is that the capacity gets spent on something else. Anything with a limited budget makes choices, and the recreations might just never be a priority. Every one of those is plausible for one civilization. The second option needs it to be true of all of them, so the two comfortable options are not comfortable. The first says almost everything dies or stalls before it matters. The second says everything that survives makes the same choice forever, with no exceptions anywhere. Reject the third, and you are holding one of those. Which raises the question of why the third follows at all, if the first two fail, and the answer is a piece of arithmetic that has nothing to do with technology and everything to do with counting. The third option follows from a piece of counting that a child could do, and the fact that it is so simple is exactly why the argument has survived 23 years of people trying to break it. Here is the whole of it. An original era happens once. Recreations of that era can happen any number of times. That is it. Everything else is bookkeeping. If a single civilization anywhere ever runs even a handful of detailed recreations of its own past, then the number of minds who believe they are living through that original era is larger than the number who actually are. Run more and the gap widens. Run many and the original becomes a rounding error. So among all the minds that ever believe they are living through a particular era, only a tiny fraction are in the original one, provided the recreations happen at all. And then the move that does the work, with no way to tell from the inside which kind you are. The honest position is to assume you are probably one of the many rather than one of the few. That last step is the one people argue about, and it is worth being precise about what it does and does not assume. It does not assume you are typical in any deep sense. It assumes that when you have a large population of minds having indistinguishable experiences, and you have no evidence that puts you in one group rather than another, you should not confidently place yourself in the smallest group. That is ordinary reasoning about probability, and it is used everywhere else without controversy. It becomes controversial here because of what it concludes. Now the objection that gets raised most, and it has real force: you cannot draw a probability out of a population you have not established exists. That is correct. The counting only tells you what fraction of minds are recreations if there are recreations. If nobody ever runs any, the fraction is 0, and the argument tells you nothing. Which is exactly why the trilemma has 3 branches instead of 1 conclusion. Bostrom is not asserting that the recreations exist. He is saying that if they do, the counting follows, and therefore you have to reject one of the first 2 options to escape the third. The argument is a fork, not a claim. There is a subtler objection, and it is the strongest one available. The counting treats all these minds as members of one population, drawn from a single pool, as though somebody shuffled them and dealt one to you. But there is no shuffle. There is no dealer. You are not a randomly selected item from a set. It is worth seeing why that objection is harder to hold than it first looks, because the same style of reasoning is used constantly without anybody complaining. When a doctor tells somebody that a treatment works in 80% of cases, they are placing that person in a population they did not choose to join, and drawing a conclusion about them from the shape of the group. Nobody objects. It is how the entire practice of medicine works. When an actuary sets a rate, when a physicist estimates how long a particle will last, when anybody reasons about anything they cannot observe directly, the move is the same. No evidence putting you in one part of the population, so do not assume you are in the unusual part. The objection says that move fails when the population is minds rather than patients or particles. Perhaps it does, but the person raising it owes an account of why it fails here and works everywhere else, and that account has been difficult to produce. That objection has a name in the literature, and it has been argued about for 2 decades without resolution. Some people find it fatal. Others find it a dodge that would, if applied consistently, break a great deal of reasoning that everybody accepts elsewhere. I do not think it is settled, and I am not going to claim otherwise. What I will say is that anybody who tells you this argument is obviously wrong, or obviously right, has not spent much time with it. Now the part I find genuinely strange, and it is about which moment gets recreated. The recreations in this argument are not of a random century. There would be no reason to spread the effort evenly across all of history. Anybody looking back would concentrate on the interesting parts, the moments where something was decided, and on the scale of a civilization's whole history, the interesting part is not the long stable stretch afterward. It is the narrow window where the thing either survives or does not. The century where a species first builds machines that could end it. The century where it first leaves its own world, or fails to. The century where the decisions that determine everything afterward get made by people who cannot see the outcome. That window, for us, is roughly now. We are inside the exact stretch that anybody looking back would find most worth looking at. Not because we are important, but because it is the hinge, and hinges are where the attention goes. That is either a coincidence or it is not, and the argument has no way to tell you which. I want to be careful here, because this is the point where this kind of video usually slides into something that sounds profound and is actually just flattering. Being at a hinge is not evidence of anything. Every generation has believed it lived at a turning point, and most of them were wrong. The feeling of significance is not data. What is different, and it is only slightly different, is that this particular century has a few things in it that are genuinely one-time events rather than felt ones. The first machines capable of ending everything, the first departure from the planet, the first artificial systems that do things nobody designed them to do specifically. Those are checkable facts about the era rather than impressions of it, and they do sit inside a very narrow window. Whether that means anything at all is a separate question, and I lean toward no. There is a cleaner way to say what is bothering people about this, and it is not really about recreations. Anybody alive right now is living through a period that will be looked back at. That is true whether or not anybody ever runs anything, and it is true of every era, but it is more true of some than others. The centuries that get studied are the ones where something turned. Everybody living through those centuries experienced them as ordinary, because that is how every century is experienced from the inside. So the sensation of living in a normal, unremarkable stretch of time is not evidence that you are. The people in the interesting centuries had it too. That is worth holding, and it is not a claim about simulations. It is a claim about how little the view from inside tells you about where you are. You cannot feel the shape of the era you are in. Nobody ever has. There is one more piece of the counting worth having, because it changes the shape of the third option. If recreations happen, they can also contain recreations. A civilization inside a recreation could, given enough capacity, run its own. Those could run more. There is no obvious point at which the nesting has to stop, other than the capacity available at the top, which means the third option is not simply that we might be one layer down. It is that the number of layers is unknown and possibly large, and that the original, whatever it was, is arbitrarily far away. There is a consequence of the nesting that is worth following, because it cuts against the argument rather than for it. Each layer costs the layer above it. Whatever is running a recreation has to pay for it out of its own resources. So a recreation is always smaller in capability than the thing running it. It cannot be larger. There is nothing to make it out of, which means the layers are not equal. They shrink. Each one has less available than its parent, and after enough steps there is not enough left to run anything at all. That puts a ceiling on the nesting, and the ceiling might be low. If each layer costs a substantial fraction of what the layer above has, you get very few layers, not many. And if there are very few, the counting changes. The argument depends on recreated minds vastly outnumbering original ones. A shallow stack with a handful of layers does not obviously produce that. So the tower everybody enjoys picturing, with layers going down forever, is the version least supported by the physics. The realistic version is short. That is either extremely disturbing or completely inconsequential, depending on a question nobody can answer, which is whether anything about being one layer down would ever show up from the inside. And that question, unexpectedly, has an answer that somebody went and looked for. Here is the question almost nobody asks about this, and the answer is stranger than the argument itself. What would actually change? Take the third option as true. We are not real, in whatever sense the argument means. Now go through what that alters about being alive tonight. Your body still works the way it works. Food still tastes of what it tastes of. If you injure yourself, it still hurts, and the hurting is not less real for running on something other than what you assumed. The people you love are still whatever they were before you found out. Whatever is happening when you are with them is still happening. Nothing about the relationship changes, because the relationship was never a claim about the substrate. Everything you have ever done, you still did. Every mistake still happened. Every good day still occurred. Nothing at all changes. That is not a consolation. It is a description. And that is the peculiar thing about this argument. It is the most disturbing idea most people ever encounter, and it has no consequences whatsoever. Compare it with almost anything else that overturns your picture of the world. Finding out your family is not what you believed changes how you understand your entire history. Finding out somebody lied to you changes what you do next. Finding out you are ill changes everything about the coming year. Finding out you are a recreation changes nothing you would do differently tomorrow morning. Take a moment on that because it is unusual and it is easy to slide past. Almost everything you believe about the world is doing some work. What you believe about your health changes what you eat. What you believe about other people changes how you treat them. What you believe about the future changes what you save. Beliefs earn their place by altering something. This one alters nothing. Whichever of the three options is true, tomorrow morning is identical, and every choice you face is the same choice with the same considerations. There is nothing to act on. No decision it informs, no behavior it should alter. Every argument that starts with, if we are in a simulation then we should, collapses on inspection, because the argument gives you no information about what anybody outside wants, whether anybody is there, or whether anything you do registers. So it is a claim with the emotional weight of a catastrophe and the practical weight of nothing at all. I find that combination genuinely interesting, and I think it explains most of the reactions people have to it. Some people find the idea terrifying, some find it freeing, a few find it obviously stupid and get annoyed that anybody takes it seriously. Notice that all three of those are reactions to the same content. The argument is identical in every case. What differs is the person receiving it, which means the reaction is telling you about yourself rather than about the argument, and that is worth knowing before you decide how you feel about it. There is one place where people think something changes, and I want to head it off because it is the most damaging misreading of this argument. Some people, on encountering it, conclude that nothing matters, that if none of this is real, then cruelty is not really cruelty, and consequences are not really consequences, and the whole thing is a game. That does not follow, and the reason is simple enough to state in one line: if the recreated minds do not experience anything, the argument never gets started, because there is nothing to count. If they do experience something, then everything that happens to them is experienced, and the cruelty lands exactly as hard as it looks. The argument requires experience to be real in order to run at all, so it cannot be used to conclude that experience does not matter. It has that assumption at the bottom of it. Anybody who reaches, so nothing matters, has taken the conclusion and dropped the premise it depends on. Now the harder version of the question, because there is one place where something does change. If the third option is true, then the recreation had a beginning and can have an end. Anything running can stop, not through catastrophe, not through anything happening inside, but because whatever is doing the running stops doing it. There would be no signs beforehand. There would be nothing to detect. It would simply not continue. Everything that exists inside it would end simultaneously, without any of it experiencing an ending, because ending requires a moment afterward to notice. That is a genuinely different kind of mortality from the ordinary one, and it is the only part of this that seems to me to have any real force. But even that changes nothing you would do. It is unpredictable, undetectable, and unaffected by anything anybody does. So it belongs on the list of things that are true or not true and that you cannot use, alongside a great many other facts about the universe. There is a way of holding all of this that I think is more useful than either the dread or the dismissal, and it comes from noticing what the word real is doing. When somebody says a recreation would not be real, they usually mean it would be a copy of something else, and copies are lesser than originals. That intuition works fine for paintings, and it does not obviously transfer. If the process running you is producing experiences, then the experiences are occurring. Something is happening. Whatever the substrate is, the events are events, and they are not a copy of some other set of events happening elsewhere. Nobody is having your afternoon somewhere else in higher resolution. Under that reading, a recreation is not a fake version of a real thing. It is a real thing running somewhere unexpected. I am not certain that is right, and there are philosophers who would take it apart, but it is at least as defensible as the automatic assumption that unreal means worthless, and that assumption usually goes unexamined because it feels obvious. There is a comparison that makes the point better than any argument, and it is one you already accept without difficulty. Every atom in your body was manufactured inside a star that exploded. That is not poetry. It is where the elements came from, and it is not seriously disputed by anybody. When most people first learn it, they find it striking for an afternoon, and then it stops mattering, because nothing about it changes what to do next. It is a true fact about your composition, with no consequences attached. The third option is the same kind of fact. It concerns what you are made of and made by, and like the stellar one, it does not reach into anything you would do. The difference is entirely in how the two are worded. One is delivered as wonder, and one as threat, and the reason people find them so different is the wording rather than the content. If somebody told you the third option using the phrasing of the first, that you are woven out of something more capable than matter, running on a substrate more durable than a body, some people would find it uplifting. Nothing about the claim would have changed, which is another sign that the reaction is coming from the receiver rather than the argument, which leaves the argument in a strange place. Three options, at least one true, no way to tell which, and a third option that would alter nothing if confirmed. The obvious next question is whether it could ever be confirmed at all, and there is a reason to think it could not. There is a reason no experience you have could ever settle this, and it is the same reason a philosopher in France worked out 400 years ago while sitting by a fire. His name was René Descartes, and in 1641 he published a short book that opens with him trying to work out what he could be certain of. His method was to doubt everything he could manage to doubt and see what survived. The senses went first, because they are known to be unreliable. Things look bent in water. Distant objects appear small. Anybody who has been badly mistaken about what they were looking at knows the senses can be wrong, and if they can be wrong sometimes, then nothing they report is certain. Then he went further, and this is the part that matters tonight. He considered the possibility that something powerful and deceptive was producing all of his experiences deliberately, not a broken sense here and there. The whole of it, manufactured, consistently, with nothing behind it. His conclusion was that he could not rule this out. There is no experience that distinguishes a world from a sufficiently thorough production of one, because the only evidence available about the world arrives as experience. That is a 400-year-old argument, and nothing since has broken it. Which means the modern version is not a new idea. The technology in it is new, the structure is ancient, and it turns up independently in several places. 2,000 years earlier, a Chinese philosopher named Zhuangzi wrote a few lines about waking from a dream of being a butterfly and not knowing afterward whether he was a man who had dreamt of being a butterfly or a butterfly now dreaming of being a man. He did not resolve it. The point of the passage is that it does not resolve. In 1981, an American philosopher named Hilary Putnam wrote up the same shape in modern terms, and it became the standard classroom version for a generation. So the question is not a product of computers. Computers gave it a mechanism, and the mechanism made it feel current. But people were stuck on this long before anybody had a machine to point at. There is something worth knowing about how Descartes was received, because it tells you how people handle arguments of this kind. He was not writing to unsettle anybody. He was trying to find a foundation, and the doubt was the tool rather than the destination. He wanted to clear away everything uncertain, so that whatever remained could be built on. The reaction then and since was that people took the doubt and left the foundation. That has happened to every argument of this shape. The unsettling half travels and the constructive half stays behind. Descartes is remembered for the demon rather than for what he thought survived it. Bostrom is remembered for the third option rather than the trilemma. In both cases, the part that spread is the part with the best story, not the part the author cared about. I think that is worth naming, because it will happen to this video too. Somebody will take the 20 minutes about whether you are real and leave the hour about whether anything survives, and the 20 minutes is the less interesting half. There is one more historical detail worth having, and it is the oldest version anybody has found. Around the 4th century before the Common Era, a Chinese philosopher named Zhuangzi wrote a few lines that have outlasted almost everything else from that period. He described waking from a dream in which he had been a butterfly, and not knowing afterward whether he was a man who had dreamt of being a butterfly, or a butterfly now dreaming of being a man. He did not resolve it and did not try. The passage is a handful of sentences, and its point is that the question does not close. 2,500 years later, 3 physicists proposed checking the arrival directions of cosmic rays. Same question. Somewhat more equipment. Now what all of that implies for anybody hoping to settle it from the inside. Everything you will ever know about the world arrives through the same channel. Sight, hearing, touch, and instruments that eventually report to those. There is no separate line, no independent confirmation, nothing that comes from outside the system to check the system against, which means any evidence that arrives could, in principle, be part of what is being produced. Find the grid in the cosmic rays and you have found something inside the world telling you about the world. A sufficiently thorough production would produce that too, if it produced everything else. That is the reason this cannot be closed by observation in the way ordinary questions can, not because nobody has been clever enough, because of the shape of the situation. There is a limit to how far that goes, and it is worth being fair about it. The unfalsifiable version, where any evidence at all can be explained away, is not the version physicists are working on. What Bean and his colleagues proposed is narrower and more useful. If somebody recreated this world using methods anything like ours, there would be a specific signature, and here is where to look for it. That is a real test of a real hypothesis. It cannot rule out every conceivable arrangement, but no test ever does. It can rule out a particular family of them, which is how science normally proceeds. So the honest position is that the general claim is untestable and a specific version of it is not, and confusing those two is where most of the bad arguments on both sides come from. There is a practical consequence of that which is worth having, because it applies well beyond tonight. An idea that cannot be wrong is not doing any work. If a claim accounts equally well for every possible observation, then no observation tells you anything about it, and believing it costs you nothing and gains you nothing. It sits in your head taking up room. That test is worth applying widely, and it disqualifies a great deal. The general version of tonight's argument fails it. The specific version, the one about grids and cosmic rays, passes, because there is an outcome that would count against it. You can use that distinction on almost anything anybody tells you about the universe. Ask what would have to happen for this to be false. If nothing would, you are being handed a story rather than a finding. I want to be fair about where that leaves the argument, because failing the test does not make it worthless. An idea can be unfalsifiable and still be a useful piece of reasoning, provided it is doing something other than making a prediction. Tonight's argument is doing exactly that. It is not predicting anything. It is showing that three comfortable beliefs cannot all be held at once. That is a service, and it does not require the argument to be testable. It requires it to be valid, which is a different property. There is one more thing from Descartes worth having, because it is the part everybody forgets. He did not stop at the doubt. He was looking for something that survived it, and he decided one thing did. Whatever else was uncertain, something was doing the doubting. The deception, however thorough, required somebody being deceived. That much could not be manufactured away, because the manufacturing needed a recipient. Whether his conclusion holds up is argued about to this day, but the move is worth noticing, because it applies directly here. Every version of tonight's argument, including the alarming one, requires that there is something it is like to be you. The whole counting exercise is a count of minds having experiences. Take away the experiencing, and there is nothing to count and no argument left. So the one thing the argument cannot take from you is the thing that makes the argument work. Whatever you are running on, something is going on in there, and that is not in question. It is the premise. What is in question is what it would cost to produce, and there the numbers get uncomfortable fast. In 1961, an engineer at IBM named Rolf Landauer worked out that thinking has a minimum price, and that the price is paid in heat. The result is the reason the whole argument runs into physics rather than staying in philosophy, so it is worth having properly. What Landauer showed is that erasing a single piece of information cannot be done for free, not because of engineering limits, and not because our machines are inefficient, because of thermodynamics. Getting rid of one bit releases a minimum amount of heat, and that minimum is set by the temperature of the surroundings and by nothing else. The number is tiny. At room temperature it is about 3 billionths of a billionth of a billionth of a joule per bit. Tiny, and not zero. And that is the whole point. It means information is physical, not an abstraction, not something floating free of the world. Handling it costs energy, and the cost has a flaw nobody can get under. There is a consequence of that worth sitting with before going further, because it applies to you directly, and it is not a metaphor. Every thought you have ever had cost energy. Not in a loose sense. Your brain runs on roughly 20 watts, about the same as a dim light bulb, and a meaningful share of that is the price of moving information around and throwing some of it away. Forgetting is not free either. Whatever it costs to hold a memory, losing one also releases heat, because erasing is the operation Landauer was writing about. So the person you are is a physical process with a running cost, paid continuously, in warmth that leaves your head and goes into the room. Which converts the question of whether anybody could run a detailed recreation of a world into a question about power, and power is something we know how to reason about. There is a second limit worth having alongside it, because together they close off the easy answers. Erasing information has a minimum cost. Processing it has a maximum speed. The maximum comes from the amount of energy available. A physicist named Hans Bremermann worked out in the 1960s that the rate at which any physical system can process information is capped by its mass, through the relationship between mass and energy that everybody knows. Put those together, and you get something restrictive. Take the entire mass of this planet, convert all of it into a machine operating at the theoretical limit, and run it for the entire age of the universe. There is a finite number of operations that machine could perform, and it is a number with about 90 zeros in it. Large, also finite, and calculable, which is the point. These are not open-ended quantities, so anybody wanting to recreate a world is not working with unlimited resources. They are working inside limits set by how much matter they can gather and how much energy they can extract from it, and those limits are known. Start with the size of the thing being recreated. There are somewhere around 10 to the 80th atoms in the part of the universe we can see. That is a 1 with 80 zeros after it. Tracking the state of every one of them at every moment would require an amount of information storage that has no relationship to anything anybody has built or proposed. And tracking is the cheap part. Updating all of it, moment to moment, according to rules, costs energy every time. Multiply the floor price of a bit by a number with 80 zeros in it, then multiply again by however many moments you want to cover, and the energy required stops being large and starts being absurd. There is a serious version of this objection published in 2025, and it concludes that recreating a universe of this size at full detail is not merely difficult, but physically unavailable to anybody operating under physics like ours. That looks decisive, and there is a standard reply, which Bostrom made in the original paper 20 years earlier. You would not have to recreate everything. The only parts that need detail are the parts anybody is examining. Everything else could be held roughly, at low resolution, and filled in properly only when somebody looks. That is not a strange idea. It is how every large piece of software that renders a world already works, and the reason is the same. Doing the full job everywhere is wasteful when almost nowhere is being inspected. Under that approach, the cost collapses. Instead of tracking every atom, you track a few billion minds and whatever is currently in front of them, at whatever detail their senses and their equipment can actually resolve. That is still an enormous number. It is no longer an impossible one. There is something uncomfortable buried in that cheaper version, and it is the part people usually enjoy until they follow it through. If only what gets examined is computed properly, then the overwhelming majority of what you believe surrounds you is not there in any detailed sense. Not the far side of the world, not the interior of anything nobody has opened, not the people you are not currently with. All of it held roughly, as a summary, sufficient to produce the right answers if anybody checks, and no more than that. Under that arrangement, a person is fully present only while somebody is looking at them. I want to be clear that this is a consequence of the cheaper version, rather than a claim about reality, and that nothing supports it. But it is what the cost saving actually implies, and it is considerably darker than the version people repeat, which usually stops at the reassuring idea that everything is rendered beautifully and somebody cares. Filling in on demand only works if nobody can catch you doing it. The moment somebody builds equipment sensitive enough to look at something more closely than the rough version was stored, the recreation has to produce detail that was never computed, and produce it consistently with everything already recorded. We do that constantly. That is what experimental physics is. Every advance is somebody looking at something more closely than anybody looked before, and the results have to agree with all previous results. So a recreation that cuts corners has to keep its story straight across every measurement anybody has ever made, at every scale anybody has ever probed, forever, retroactively. That is not obviously impossible. It is a considerably harder problem than it first sounds. It is worth being concrete about the scale of that bookkeeping, because it is the part people wave through. Somebody in 1850 measured the speed of light. Somebody in 1919 measured how much starlight bends past the sun. Somebody last week measured the mass of a particle to 11 decimal places. Every one of those results has to be consistent with every other one, and with everything measured in between, and with everything that will be measured afterward. not approximately, to the precision of whatever equipment is being used at the time, which keeps improving, and nobody announces in advance what they are going to look at. A recreation cutting corners would have to fill in, on demand, at arbitrary precision, in a way that agrees with 150 years of prior results that were themselves filled in on demand, without ever producing a contradiction anybody notices. Every physicist alive is, without intending to be, running a continuous audit. That does not prove anything. It does mean that the cheap version is not as cheap as it sounds, because the cost of consistency grows with everything ever checked, and nothing ever gets removed from the list. There is a specific version of this difficulty that is worth its own moment, because it may be the strongest technical objection anybody has raised. Quantum systems are extraordinarily expensive to reproduce with ordinary computation. The cost grows explosively with size. Doubling the number of particles does not double the work. It squares it, or worse. Past a few dozen particles, the requirements exceed anything that could be built out of the visible universe. That is not a claim about our current machines. It is a structural feature of how the mathematics behaves. You can get a sense of the scale of it without any of the mathematics. To keep track of 30 particles behaving quantum mechanically, you need somewhere around 1 billion numbers. 60 particles needs 1 billion billion. 300 particles needs more numbers than there are atoms in everything you can see. 300 particles is nothing. It is a speck. You are made of something like 10,000 billion 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 of them. So, reproducing you, at the level physics says you are actually operating at, is not a large problem or an expensive one. It is a problem whose size exceeds the universe by a margin that has no name. That is either the strongest objection anybody has, or an indication that the reproduction would not work at that level at all, and would use something coarser that only has to look right, which is the same fork as before, arriving from a different direction, and in 2017, 2 physicists showed something sharper. For a whole class of quantum systems, the difficulty is not merely large, it is provably not reducible by any clever method. The obstruction is built in. The obvious reply is that the recreation would run on quantum hardware rather than ordinary hardware, which sidesteps the problem entirely. The reply to that is that this changes what is being claimed. If reproducing this world requires a machine built from the same physics as this world, running at comparable scale, then the recreation is not a simplified copy of reality. It is a thing about as large and as expensive as the reality it copies, which raises a fair question about whether the word simulation is still doing any work at that point. There is a version of that thought worth following, because it turns the whole argument inside out. If reproducing a world in full requires a machine as large and as expensive as the world, then the distinction between the world and the reproduction starts to dissolve. A thing that costs as much as reality, behaves exactly as reality behaves, and contains everything reality contains, is not a description of reality. It is another one. Under that reading, the third option stops being a claim that we are fake and becomes a claim that there is more than one of these, which is a much less alarming statement, and possibly not even a distinguishable one. I find that the most interesting move available against the frightening version, and it does not require rejecting anything. It accepts the whole argument and then points out that the word doing the frightening is not carrying its weight. Whether that holds depends on the cheap version being impossible. If corners can be cut, then the reproduction genuinely is smaller and simpler than the original, and the distinction comes back. So everything turns on the same question again. How much can be left out before somebody notices? There is one more consideration, and it cuts the other way, in favor of the argument. Nothing requires the outer world to have the same physics as this one. Every calculation about energy costs and quantum difficulty assumes the machine is subject to the rules we know. If the containing world runs on something else, with different limits, then all of those numbers are irrelevant. That is not a satisfying position, because it makes the claim unfalsifiable in exactly the way I complained about in an earlier video. Any objection can be waved away by declaring that the rules are different out there. So the honest state of the cost question is this: recreating everything, at full detail, under physics like ours, appears to be out of reach. Recreating only what gets examined is far cheaper and possibly reachable, but has to survive every measurement anybody ever makes. And if the containing world runs on different physics, none of the numbers apply, and nobody can say anything at all. That is 3 different answers depending on an assumption nobody can check, which is roughly where this whole subject sits. There is a consequence of the cost question that is easy to miss, and that matters more than the arithmetic. If it turns out that nobody can afford to do this, then the third option is dead, and you are left holding the first 2. That is not the relief it sounds like. The first says almost everything alive that gets this far dies before it matters. The second says everything that survives makes the same choice, forever, everywhere, with no exceptions. So proving that we are real does not get you out of anything. It removes the strange option and leaves the 2 grim ones, and one of those has to be true. Every headline announcing that the universe is not a simulation is also, if you follow it, an announcement that either almost nobody survives or that everybody who does behaves identically forever. Nobody reports it that way, because the reassuring half is the half that fits in a headline. That is the shape of this whole argument, and it is why it has lasted. There is no comfortable exit. There are only 3 doors, and you have to walk through one. What would change everything is finding a way to check from the inside, and somebody worked out how to try. In 2012, 3 physicists published a paper proposing that this question could be settled by looking at the sky, and the reasoning behind it is the most elegant thing in tonight's video. Their names were Silas Bean, Zoré Davoudi, and Martin Savage, and they did not arrive at this from philosophy. They arrived at it from their day job. Here is what their day job is. There is a branch of physics that already recreates a piece of the universe, not a metaphorical piece, an actual volume of space, with the actual rules that govern how the strongest force behaves, running on very large machines. The volume is small, roughly the size of an atomic nucleus. The rules are the ones that hold protons and neutrons together, and they are too difficult to solve with pen and paper, so the only way to get answers is to build the space and let it run. And here is the part that matters. To do that at all, you have to lay the space out on a grid. Continuous space has infinitely many points in it, and no machine can hold infinitely many anything. So the space gets divided into a lattice of discrete positions, with a fixed spacing between them, and everything happens at the grid points, and nowhere in between. This is not a shortcut anybody is embarrassed about. It is the standard method, it has been refined for decades, and it produces results that match experiments to remarkable precision, which means the only working example anybody has of recreating a piece of this universe uses a grid, because there is no other way to do it. Now the leap they made. If our own attempts to recreate a piece of the universe require a grid, then anybody else's attempt to recreate the whole thing would presumably require one too. Different scale, same constraint, because the constraint comes from the mathematics rather than from our particular limitations. And a grid leaves a fingerprint. Space, as far as anybody has been able to measure, treats every direction the same. There is no preferred axis, no orientation that behaves differently from any other. Turn an experiment around and it gives the same answer. A grid cannot do that. Lay points down in a regular arrangement, and you have automatically created special directions. Along the rows, along the columns, diagonally through the corners. Those directions are not equivalent to each other, because the spacing between points differs depending on which way you go. For almost everything, the difference is far too small to notice, but the effect grows with energy, and at extreme enough energy it should become detectable. So their proposal was this: look at the most energetic things that arrive here from space, and check whether they show any preference for particular directions. Those things are cosmic rays. Cosmic rays are individual particles, mostly protons, arriving from somewhere out in the galaxy or beyond it, moving at very nearly the speed of light. Most are unremarkable. A very small number carry an amount of energy that is genuinely difficult to accept. The record holder, detected in 1991, carried about as much energy as a fast baseball in one subatomic particle. It was nicknamed the "Oh my God" particle, and nobody has fully explained where it came from. Those extreme ones are rare, A patch of ground the size of a city might catch one a century, which is why the instrument built to catch them covers an area larger than some countries. There is an array in Argentina with roughly 1,600 separate stations spread across 1,200 square miles of open plain, sitting there waiting for individual particles. That array, and others like it, is where this test would be run. Before the prediction, it is worth knowing what a cosmic ray actually does when it arrives, because none of them reach the ground. A proton carrying that much energy hits the top of the atmosphere and destroys the first thing it touches. That collision produces a spray of new particles, each carrying a share of the energy, and each of those hits something and produces more. What began as one particle becomes a cascade spreading downward and outward, and by the time it reaches the surface, it can be billions of particles covering an area of several square miles. That is why the tanks are spread out rather than clustered. Nobody is trying to catch the original. They are catching different parts of the same shower at different places, and working backwards from the timing to find the direction it came from. Every one of those showers has been happening over your head your entire life. Several pass through your body every second, at the low energy end. The extreme ones are rare, and the atmosphere absorbs all of it, which is one of the several reasons anybody is alive down here. Now the specific prediction, and it has two parts. The first concerns a limit. There is a known ceiling on how much energy a cosmic ray can have and still reach us from far away, because above a certain point the particles start interacting with the leftover glow of the early universe and lose energy along the way. That ceiling has been measured. Bean and his colleagues pointed out that a grid would impose its own ceiling, and that the observed one puts a bound on how fine the grid could be. Their number works out to a spacing far smaller than anything currently reachable by experiment, which means if there is a grid, it is very fine. The second part is the actual test. Above that energy, the arrival directions of cosmic rays should not be spread evenly across the sky. They should show a slight preference for the axis of the underlying grid, and that preference would be a pattern nothing else would produce. Nobody has seen such a pattern. The arrival directions look as even as anybody can measure. It is worth knowing how hard that measurement is, because the evenness is not obvious and did not come free. The extreme cosmic rays are charged particles, and charged particles bend in magnetic fields. Our galaxy is full of magnetic fields, weak but enormous, and everything arriving here has been curving on the way in for however long it has been traveling. So the direction a particle arrives from is not the direction it came from, and working backwards requires knowing the shape of a magnetic field spanning 100,000 light years, which nobody knows well. You can see the problem. Every particle you catch has taken a curved route through a landscape nobody has mapped, and you are trying to infer something about the geometry of space from where it ended up. That smears out any pattern that might be there. A grid signature would have to survive all of that bending before anybody could see it, which means the evenness observed so far is weaker evidence than it looks. It is consistent with there being no pattern. It is also consistent with there being a pattern that the galaxy has stirred into invisibility. That is the honest state of the test, and it is less conclusive in both directions than the coverage of it usually suggests. It is worth stopping on what it would have meant if they had, because the consequence is larger than anything else in tonight's video, and it never gets spelled out. A preferred direction in the highest energy cosmic rays would not be evidence that something is watching us. It would be evidence that this world has a grain, that space is not continuous but built out of discrete positions, and that everything anybody has ever done happened at the points of a lattice somebody laid down. Every person who has ever lived, every thought anybody has had, every world in the sky, all of it running on a structure with a spacing, and it would mean the first two options are gone. Somebody survived long enough, somebody chose to look back, which would settle the question this channel keeps circling, because it would mean at least one civilization made it past whatever kills the rest. That is the strange shape of this result. The finding that would tell you that you are not real is also the only finding that would tell you somebody, somewhere, survived. Nobody has found it. The sky stays even, and both of those remain open. That does not settle anything, and the reason is worth stating clearly. Finding nothing constrains how fine the grid could be, and pushes the answer to smaller and smaller spacings. but a sufficiently fine grid produces effects too small to catch with anything anybody can build. So the test can rule out coarse grids and cannot rule out fine ones. That is a real result, and it is not the dramatic one. There is also an assumption underneath it that deserves to be named, because it is a large one. The whole test assumes that anybody recreating a universe would do it roughly the way we do it. Same kind of grid, same kind of approach, same underlying mathematics. There is no particular reason that should be true. It is 100 years of our own methods projected onto somebody with vastly more capability, which is the same mistake made by every generation that assumed the future would look like a bigger version of the present. There is a human detail about that array in Argentina that I keep coming back to. Those 1,600 stations are tanks of water sitting in open country, each one waiting for a particle. Most of them will go their entire operational lives without catching one of the extreme ones. The people who built it knew that going in, they are structures placed on a plane in the hope that something will arrive, not on any schedule, not in response to anything anybody does. The particles come or they do not, and everybody waits. That is a strange way to spend a career, and it is the same way this channel keeps finding people spending them. Somebody at a telescope in West Virginia, listening to 2 stars for 4 months. Somebody going through printouts at a kitchen table days after the fact. Somebody watching a tank of water underground for decades, waiting for a proton to fall apart. The work is mostly waiting, and mostly nothing arrives, and people do it anyway. What I find valuable about the paper is not the answer. It is that 3 working physicists took a question everybody had filed under philosophy and produced a specific, checkable prediction from it, using equipment that already exists on data already being collected. That is the difference between a question and an idea. A question has a way to be wrong. There is a broader lesson in how that paper came about, and it is not about simulations at all. Those 3 were not philosophers who learned some physics. They were physicists doing ordinary work who noticed that their own method had a strange implication. They spend their careers laying space out on a grid because it is the only way to get answers. One day somebody looked at that and thought, if this is what recreating a piece of the universe requires, then anybody else recreating a universe faces the same requirement, and requirements leave marks. That is where most useful ideas come from. Not from setting out to answer a large question, but from noticing that something you do routinely has a consequence nobody has followed. The wow signal was found by a man going through printouts days late at his kitchen table. The first pulsar was found by a graduate student noticing a bit of scruff. The expansion of the universe was found by 2 teams measuring something else and refusing to accept their own answer. None of those people were looking for what they found. There is a version of this that applies to the cosmic rays specifically, and it is a small, nice thing. The array in Argentina was not built to test whether the universe is a recreation. It was built to work out where the extreme cosmic rays come from, which is a completely ordinary and completely unsolved problem in astrophysics. The test in this video runs on material that is being collected anyway, for other reasons, by people who mostly do not care about the philosophy, which means it costs nothing extra. The answer, if it ever arrives as a side effect of somebody else's work. There is one more thing about that array worth knowing, and it concerns you more directly than anything else in this stretch. The showers those tanks are catching pass through everything, including people. At the low energy end, several particles from space go through your body every second of your life, and have done since before you were born. Some of that has consequences. A small share of the mutations in any population comes from exactly this, from particles arriving out of the galaxy and passing through a cell at the wrong moment. Which means the same thing that might one day tell you whether this world runs on a grid has also been quietly editing the species for 4 billion years. That is not a connection anybody planned. It is just what happens when you look closely at something ordinary and find it is doing more than one job. And the reason the whole thing has become newsworthy again is that in the last 2 years, several groups have argued that the answer is already available and that it is no. In October of 2025, a paper appeared claiming to have settled this permanently, and the headlines that followed said the universe had been proved not to be a simulation. The claim is stronger than anything anybody had made before, and it deserves a careful hearing rather than either the enthusiasm or the eye-rolling it received. Two separate lines of attack arrived at roughly the same time, and they work completely differently, so take them one at a time. If you only remember one thing about them, make it that they are attacking different targets, which is why they can both be right and still not settle anything between them. The first is about cost, and it is the one built on physics. Published earlier in 2025, it takes the energy argument seriously and pushes it all the way through. Information is physical, handling it costs energy. Reproducing this universe in the detail we appear to experience requires an amount of energy that exceeds what is available to anybody operating under the rules we can see. The conclusion in the title is careful. It says nearly impossible rather than impossible, and the qualifier is doing real work. The second line is more ambitious, and it is about mathematics rather than energy. The argument, from a group working in Canada, runs on a result proved in 1931 by a logician named Kurt Gödel, and getting the result right matters because it is one of the most abused theorems in existence. The story behind it is worth having, because it explains why the result landed so hard. At the start of the 20th century, the most influential mathematician alive set the field a goal. His name was David Hilbert, and what he wanted was a complete foundation, a set of rules from which every true statement in mathematics could be derived, and which could be proved consistent using nothing outside itself. It was not an unreasonable ambition. Mathematics had been getting steadily more rigorous for a century, and this looked like the final step. A great deal of very serious work went into it. In 1931, a 25-year-old in Vienna showed it could not be done. Gödel's result comes in two parts, and the first is the one that matters tonight. Any system of rules powerful enough to describe ordinary arithmetic will contain statements that are true within that system and cannot be proved by it. Not because nobody has been clever enough, because the system cannot reach them, in principle, ever. The second part is worse. Such a system also cannot prove its own consistency. If it could, that would itself be a sign that something is wrong with it. The method he used is the part people find beautiful. He worked out how to make statements about arithmetic into numbers, so that arithmetic could talk about itself, and then constructed a statement which effectively says that it has no proof. If it is false, it has a proof, and something false is provable. If it is true, then here is a true thing with no proof. Either way, the goal is unreachable. Hilbert's program did not survive it. Gödel was 25, and the paper is about 20 pages. You are entitled to find that result strange rather than obvious, because it is. What it says is that truth and provability are different things, and that the gap between them cannot be closed by any amount of work. Most people assume, without ever putting it into words, that if something is true there must be a reason, and that a sufficiently patient person could find it. That assumption is false, demonstrably, and has been for nearly a century. Whether you find that unsettling depends on how much you had invested in the assumption. Mathematicians at the time were badly shaken. Almost everybody else carried on unaffected, which is the usual pattern. None of this is a claim about difficulty, it is a claim about limits that no amount of effort removes. The move the 2025 paper makes is to apply that to any complete description of reality. If a full account of the universe would have to be a system of that kind, then there are truths about the universe that no set of rules can generate, and anything running on rules cannot produce what rules cannot reach. So a universe that contains truths beyond any rule system cannot be entirely the output of one. Their phrase for what would be required is non-algorithmic understanding, meaning something that gets to true statements by a route other than following steps. If that holds, it does not merely make the recreation expensive, it makes it the wrong kind of thing entirely, in a way no amount of capability fixes. Now the honest handling, because this is where I part company with how it was reported. It was covered as a proof, and the word proof did an enormous amount of work in headlines that a careful reading does not support. Here is the difficulty, stated plainly. The argument needs the universe to contain truths that no rule system can produce. That is not established. It is an assumption about the nature of reality, and it happens to be the assumption most likely to deliver the conclusion the argument wants. Gödel's theorem is about formal systems of a particular kind. Whether the physical universe is a formal system of that kind, or is anything like one, is exactly the question at issue. Using a theorem about formal systems to settle whether reality is a formal system requires assuming the answer somewhere. That objection is not mine, and I am not qualified to originate it. It is the standard response to every attempt to use this theorem outside mathematics, and there have been many, going back decades. The most famous attempt was about minds rather than universes, and the shape of it is identical, so it is worth knowing how that one went. Starting in the 1960s, several thinkers argued that Gödel's result shows human understanding cannot be a matter of following rules. The reasoning was that a person can see the truth of a statement that no rule system can prove, and therefore the person is doing something no rule system does. A very well-known physicist made an elaborate version of this in the 1980s and 90s, and it sold a great many copies. The responses came quickly and they have held up. The main one is that a person only sees the statement is true if they are certain the system is consistent, and nobody has that certainty. Take away the assumption and the person is in the same position as the machine, able to say the statement is true given consistency, and unable to establish consistency. So the apparent advantage disappears when you look at what is actually being claimed. That exchange ran for 30 years, involved a great many capable people, and did not end with the theorem being successfully applied outside mathematics. Which is the relevant precedent here, because the 2025 argument has the same structure aimed at a different target. None of that proves the new version fails. It does mean it inherits a long history of similar attempts that did not survive contact with logicians. Which brings us to the part that tells you how settled this really is. A formal commentary responding to the 2025 paper appeared in the same journal in 2026. That is what disagreement looks like in this field. Not a press release, a commentary in the same venue going through the argument. The existence of that response is itself the most useful piece of information here, and it is the piece nobody reported. A result that had genuinely closed a question does not attract a formal reply within months. Results that are contested do. So the honest position on the impossibility arguments is this. The energy argument is strong, and it is aimed at recreating everything at full detail, which is the version Bostrom already conceded nobody would attempt, against the cheaper version, where only what gets examined is computed properly. It lands with much less force. The mathematical argument is more ambitious, rests on an assumption about the universe that is roughly the thing in dispute, and is being argued with rather than accepted. Neither of them settles it. Both of them narrow it, which is genuine progress and considerably less exciting than the coverage suggested. You are allowed to find that unsatisfying. Most people want a subject like this to resolve, and it does not, and the reason is not that anybody is being evasive. What has actually happened over 23 years is that the space of possible answers has been carved down. Some versions have been ruled out on energy, some on the difficulty of reproducing quantum systems, some on the absence of a grid signature in the sky at the course end. None of that is nothing. It is what progress looks like on a question that may not have an accessible answer, and it is the same shape as the progress on whether anybody else is out there, where 65 years of listening has ruled out the loud, obvious version and left everything else open. You are not going to get a verdict from this. What you get instead is a much better map of where the uncertainty actually lives, which is a real thing to be handed and is not what anybody wants. There is something worth saying about why you keep hearing that this has been settled, and it is not anybody being dishonest. A paper arguing that something is nearly impossible under a specific set of assumptions is a normal contribution. It becomes, scientists prove universe is not a simulation, somewhere between the paper and you, and every step of that journey is somebody doing their job in a way that is individually reasonable. The researchers write a careful abstract. A press office summarizes it for people who will not read it. An outlet summarizes the summary. An aggregator summarizes that. By the time it reaches you, the qualifiers are gone. because qualifiers are the first thing dropped when text gets shorter. You are almost never reading the claim. You are reading the fourth summary of it, and the load-bearing assumption was cut at step 2. That is not a reason to distrust everything. It is a reason to notice that the confidence in a headline is manufactured by the process rather than present in the work, and that the original is usually a short document anybody can find. For this particular one, the original says nearly impossible, and says under what conditions, and the conditions are the interesting part. There is a broader point here that I think is more useful than the specific dispute, and it is about how to read this kind of story. When a headline says something has been proved, the useful question is what had to be assumed to get there. Almost every dramatic claim in this area survives entirely on an assumption placed early and never examined again. The assumption that a recreated mind would experience anything. The assumption that anybody would use a grid the way we use a grid. The assumption that the universe is the kind of system a theorem about arithmetic applies to. None of those are unreasonable. All of them are load-bearing, and once you learn to look for the load-bearing assumption, you will find it inside about 2 minutes. In almost every argument of this type, including the ones I have made tonight, the argument itself has one too, and it is time to say what it is. Take the third option off the table entirely, and the argument still does not let you go, and this is the part I most want you to leave with. Assume the recreations are impossible, assume the energy cost is prohibitive, the mathematics forbids it, and nobody anywhere will ever run one. Assume we are as real as anybody has ever hoped. 2 statements remain, and at least one of them is still true. Almost every civilization that reaches roughly where we are dies before it becomes capable of anything much larger. Or almost every civilization that survives to that point declines, universally and permanently, to look back at itself in any detail. Those are the leftovers, and neither is a small claim. The first is the one this channel keeps arriving at from different directions, and it is worth naming what it means without any of the machinery. It means that being where we are now is not a stage on the way to somewhere. It is a filter, and almost nothing gets through it. That claim is not made by the simulation argument alone. It comes out of the silence in the sky. It comes out of the emptiness of every world anybody has examined. It comes out of the fact that nothing has ever crossed the space between stars and arrived here, in a galaxy old enough to have been crossed many times over. 4 different lines of reasoning, from 4 different starting points, and they keep converging on the same possibility. That convergence is the single most underrated thing in this whole subject. When one argument points somewhere, it might be the argument. When several built from different materials point at the same place, the conclusion is harder to attribute to any one of them being flawed. There is a reason that first leftover keeps arriving from every direction, and it is worth stating without any of the surrounding machinery. It is what the evidence looks like. The sky has nothing in it. Every world anybody has examined closely is dead. Nothing has ever crossed the distance between stars and arrived here. Nobody has answered in 65 years of listening. And the only step in the history of life on this planet that looks genuinely improbable happened once and never repeated. None of those is a theory. They are the situation. Theories are what get built on top to explain them, and every theory built so far has ended up needing something like the first option true. It makes it the thing you have to argue against, rather than the thing somebody has to argue for, and most people have the burden the wrong way round. The comfortable picture is the one carrying the debt. Now the second leftover, which gets less attention and is stranger the longer you look at it. Every surviving civilization declines, forever, without exception. Consider what that requires. Not that most decline, that all of them do, across however many there are, for however long the universe permits, with no outlier ever. Nothing else in nature works like that. Populations produce variation. Get enough of anything and you get the unusual case. For the second option to hold, there would have to be something that makes the choice not a choice. Some feature of the situation that forces the same outcome on everybody, regardless of what they value or how they think, which would mean either that the capability is not actually reachable, or that something about reaching it changes what a civilization wants in a uniform way. Both of those are large claims about the shape of the future, made from a sample size of 0. So here is where all of it lands. There is no comfortable option, there is a strange one, and two that are worse in different ways, and at least one of them describes the universe you are in. Most treatments of this subject present the strange one, and stop, because it is the one with a story attached. The two grim ones do not photograph well, but if you reject the strange one, and most people do instinctively, then you have chosen one of the others by default, usually without noticing you chose. There is a way of feeling the weight of that which does not require any of the machinery, and it takes about 30 seconds. Think of somebody you know who is young, a child, or somebody at the start of things. Whatever you assume about what their life will look like in 50 years, and whatever you assume about the world they will be living in, you are relying on the comfortable picture, not consciously, but every ordinary expectation about the future has it underneath. That assumption might be perfectly fine. Most people who ever made it were right about their own lifetimes, which is the only stretch anybody can check. What the argument does is point out that the assumption is doing work, and that several independent lines of reasoning give reasons to examine it, and that nobody has an answer to those reasons. It does not tell you the assumption is wrong. Nothing in tonight does. It tells you it is an assumption, which most people had not noticed, and that is the entire contribution. That is the actual value of the argument, and it is not about whether anything is real. It is that it takes something almost everybody believes without examining it, which is that civilizations generally survive and grow and eventually do interesting things, and shows that this belief has a cost. You cannot hold it and also believe you are real unless you add something else that nobody has been able to supply. That is an uncomfortable thing to be handed, and it is the honest content of the paper. There is a way of testing whether you actually hold the comfortable picture, and it takes about a minute. Ask yourself what you expect the galaxy to look like in 10 million years, assuming things go reasonably well. Most people, asked that, produce something like a spread-out civilization, structures around stars, traffic between systems, not a specific vision, but a general sense that the direction of travel is outward and upward. Now ask why the galaxy does not look like that already, given that it has had 13 billion years and we have had 100,000. The comfortable picture requires us to be the first, or nearly. Everybody who holds it is quietly assuming that in a galaxy of a couple 100 billion stars, across an age of 13 billion years, nobody got here before us. That is a strange assumption to hold without noticing you are holding it, and almost everybody holds it. The alternatives are the two leftovers. Either the ones who came before did not make it, or they made it and stayed quiet and unrecognizable forever, every time. There is a second version of this test that is closer to home. Ask what you expect this species to be doing in 1,000 years. Whatever answer comes to mind, notice that it assumes there is a species doing something in 1,000 years. That is the assumption the first option denies, and it is the one everybody makes by default because the alternative is not a thought most people carry around. I am not asking you to carry it around either. It is not useful, it is not actionable, and dwelling on it does nothing for anybody. What is worth carrying is smaller, that the default assumption is an assumption, and that several completely independent lines of reasoning give reasons to doubt it. One last thing about the man who wrote it, because it says something about how this gets received. Bostrom has spent 2 decades saying he does not claim we are in a simulation, and being quoted as claiming exactly that. His actual position, stated repeatedly, is that he finds the three roughly comparably likely and has no strong preference among them. That is a remarkably unsatisfying thing to say in public, and he has kept saying it. The version that travels is always the dramatic third. The two options about death and refusal do not make it into the retelling, and they are the ones with teeth. So if you carry anything out of tonight, carry the shape rather than the conclusion. 3 doors, no fourth, and the frightening one is not the one everybody talks about. In 1950, over lunch at Los Alamos, a physicist named Enrico Fermi asked where everybody was, and he was asking the same question as the paper this video is about, from the other end. He was not thinking about recreations, he was thinking about the galaxy being old and crossable and apparently untouched. The two arguments have nothing in common on the surface. One is about counting minds, the other is about the absence of anybody in the sky. They were made half a century apart by people working in different fields on different problems, and they converge on the same answer. Fermi's version runs like this. The galaxy is about 13 billion years old and roughly 100,000 light-years across. Even at speeds requiring no new physics, crossing it takes a few tens of millions of years, which against 13 billion is an afternoon. So anybody who ever started would have finished long ago, and this solar system would show it. It shows nothing. So either nobody ever started, or nobody lasts long enough to start. Bostrom's version runs the other way. If anybody survives and becomes capable, the counting makes us probably not real. We appear to be real. So either nobody survives, or nobody who survives does the thing. Different premises, different reasoning, the same first option sitting at the end of both. That is the thing I would most want somebody to notice about tonight, and it is the reason this argument belongs on a channel about space, rather than in a philosophy class. It is not really a video about whether you are real. It is another route to the same wall. There is a third route, and this channel has walked it too. Every world anybody has looked at closely is dead. Mars had rivers and lost them. Venus probably had oceans and boiled. The moon has no air, Mercury has none, and the ice moons have not been checked properly. That is not an argument, it is an inventory, and it points at the same place. Worlds get their chance and lose it, and you are standing on the only one anybody has found that did not. And a fourth. 65 years of listening to over 1 million stars, the plane of the galaxy and 100 galaxies beyond it, and nothing has ever answered. 4 independent approaches. Philosophy, arithmetic, geology and radio. None of them was built to support the others. All 4 leave the same possibility standing, that the stretch between where we are now and anything larger is a stretch almost nothing crosses. It is worth walking each of the 4 out to where it stops, because they fail in different places, and that matters, and because knowing where an argument runs out is more useful to you than knowing where it starts. Fermi's version stops at a question about speed and motive. It assumes anybody who lasts would spread. If lasting and staying home is the ordinary outcome, the argument dissolves, and there is no good reason to think spreading is inevitable. Everything a civilization needs is available in its own system, and there is nothing worth hauling across 4 light-years. The silence stops at a question about method. 65 years of listening is a great deal by human standards, and a hot tub of water compared with every ocean on Earth by the standards of what would have to be covered. And it assumes anybody out there would be using radio, which is 1 century of our own technology projected outward. The dead worlds stop at a question about sample size. 4 candidate environments around 1 ordinary star, 2 of them never properly examined. That is not a survey, it is a single data point with error bars nobody can calculate, and you should treat any conclusion drawn from it accordingly. And tonight's argument stops at a question about experience. If a recreated mind has none, the counting has nothing to count. So each one has a specific place where it runs out, and the places are all different, which is the reason the convergence is worth something. An objection that kills one of them leaves the other 3 standing. To clear the whole field you need 4 separate objections, and nobody has 4. I want to be careful about how much weight that carries, because convergence can be an illusion. If 4 arguments all rest on one shared assumption, they are not 4 arguments. They are one argument wearing 4 coats, and the convergence proves nothing. Do they share one? Partly. All 4 assume that a civilization which lasts would become visible in some way, whether by spreading, by transmitting, by building, or by running recreations. If that assumption is wrong, if lasting and staying quiet and staying home is the normal outcome, then all 4 dissolve together. That is the single load-bearing assumption underneath the whole field, and it is not established. It is a projection of what we think we would do onto everybody, forever. So the honest version of the convergence is this. 4 lines of reasoning agree, and they share one premise, and if that premise fails, they fail together. That is weaker than 4 independent confirmations, and considerably stronger than any one of them alone. What it does establish, and this part is not in doubt, is that the ordinary comfortable picture does not survive contact with any of them. The picture where civilizations generally last and grow and spread and build, and where the universe is broadly full of that, and where we are an unremarkable example of it, that picture is contradicted by the empty sky, by the dead worlds, by the silence, and by the counting. Something about it is wrong. Nobody knows which part. There is something worth noticing about the people who produced these four, because it is not what anybody would expect. Fermi was a physicist, making a remark at lunch. He never published it, never worked on it, and the account survives only because somebody at the table wrote it down. 35 years later, Bostrom is a philosopher who spends most of his time on risk and has said for 23 years that he is being misquoted. Bean, Davudi and Savage were doing routine work on the strong force and noticed an implication, and the silence was mapped by people who mostly wanted to build better radio equipment. Not one of these came from somebody setting out to answer the largest question available. All of them came sideways, out of somebody doing something else and noticing, which is worth keeping in mind whenever a field looks like it has a grand program. It usually does not. It has a lot of people doing careful, narrow work, and occasionally one of them looks up. There is a fifth route that this channel has not walked yet, and it is worth naming, because it comes from biology rather than from astronomy. On this world, life appeared almost immediately once the surface stopped being sterilized. Then everything alive stayed a single simple cell for about 2 billion years, half the history of the planet. Then one cell ended up inside another and survived, and every plant and animal and fungus descends from that single event, and it never happened again. Once, in 4 billion years, in an environment saturated with life and full of opportunity. That is a fifth line, from a completely different discipline, and it points at the same thing, that somewhere in the chain from a dead rock to something that can ask these questions, there is a step almost nothing takes. It differs from the other four in one important way, and it is the difference that makes it valuable. It is the only one based on something anybody has actually observed. The others reason from absence. This one reasons from a fossil and genetic record that exists and can be examined. That does not make it decisive. One planet is one planet, but it is the only member of the set that rests on a thing rather than on the lack of a thing, and that is worth more than its share. And every one of those routes, followed carefully, ends up somewhere near the same uncomfortable place, which is that this stretch we are currently standing in is not a stage anybody should assume gets past, which is the honest note to end the argument on, and it is not the note the popular version ends on. The popular version ends with a shiver about whether any of this is real, and then everybody carries on with their day, which is the correct response because nothing follows from it. The version in the paper ends somewhere harder. It says that if you are confident this is all real, and most people are, then you owe an account of why the sky is empty, why every world is dead, why nothing has ever answered, and why nobody ever built the thing. Nobody has that account. Not the people who study it, not the people who dismiss it, not me. What everybody has instead is a preference about which of the 3 doors to walk through, and preferences are not evidence. You have one too. It arrived somewhere in the last 2 hours, probably without you deciding on it, and it is worth knowing which one it is. Most people, offered these 3, quietly reject the third on the grounds that it is absurd, and then never look at what they have accepted by doing so. If that is where you have landed, you are holding either the extinction claim or the universal refusal claim, and it is worth knowing which. Some people take the third because the other 2 are unbearable, which is a reason to prefer a belief rather than a reason to hold it. And a few conclude the whole thing is a word game and walk away, which is a respectable position, and requires an account of why the counting works everywhere else. None of those is wrong. What would be wrong is not noticing you had chosen. Let's pull every thread we've followed tonight together, because the popular version of this argument keeps only one of them, and it is the wrong one. We started with the correction. The claim is not that we are in a simulation. It is that 3 statements cannot all be false at once, and you do not get to choose which one you keep. a philosopher at Oxford, published it in 2003, has spent 23 years saying he does not claim we are simulated, and has been quoted as claiming exactly that ever since. We found that the first of the three is about death. Almost every civilization that reaches roughly where we are now stops before it becomes capable of anything larger. That is not a philosophical curiosity. It is the same conclusion that comes out of pointing instruments at the sky and hearing nothing, and it is the option nobody repeats. We found that the second is stranger the longer you look at it. Every civilization that does survive declines, universally and permanently, to recreate its own past. Not most, all of them, everywhere, forever, with no outlier ever. Nothing else in nature behaves that uniformly. We found the counting that makes the third follow. An original era happens once, and recreations can happen any number of times. So if they happen at all, the minds who believe they are living through the original vastly outnumber the ones who are. That is the whole engine, and it rests on a premise nobody has demonstrated, which is that a recreated mind experiences anything at all. We found that nothing would change, not the taste of food, not whether an injury hurts, not the people you love, not anything you did. The most disturbing idea most people ever meet has no consequences whatsoever, and the three common reactions to it, terror, relief, and irritation, are all reactions to identical content, which means they are telling you about yourself. We found the question is 400 years old at least. A man by a fire in 1641 worked out that no experience can distinguish a world from a thorough production of one, because the only evidence about the world arrives as experience. 2,000 years before him, somebody woke from a dream about a butterfly and could not settle which way round it went. The technology is new, the problem is not. We found that thinking has a price, paid in heat, set by thermodynamics rather than by engineering. Your brain runs on about 20 watts, and a share of that is the cost of handling information and throwing some away, which turns an abstract question into an arithmetic one about energy, and the arithmetic says recreating everything at full detail is out of reach. Recreating only what somebody is currently examining is far cheaper, and implies that most of what you believe surrounds you is not there in detail until it is checked. We found a real test, proposed by three working physicists who arrived at it from their day job. Recreating a piece of this universe requires laying space out on a grid, because no machine holds infinitely many points. A grid has preferred directions, so the highest energy cosmic rays arriving here should show a slight preference for those directions, and 1,600 tanks of water on a plain in Argentina have been waiting for them. The sky stays even. That rules out coarse grids and cannot rule out fine ones. We found that in 2025, two separate groups argued the whole thing is impossible, one on energy and one on a theorem about the limits of formal systems, and that the headlines said proved. We found that a formal commentary responding to it appeared in 2026, which is what an unsettled question looks like. And we found that taking the third option off the table entirely does not release you. Two statements remain, and at least one is true, and both are about the same wall this channel keeps arriving at from other directions. The empty sky says it. The dead worlds say it. 65 years of silence says it. Nobody knows. The three options are roughly comparable in plausibility, and the man who wrote them has said so consistently for 23 years. What can be said is narrower. There is no fourth door. The comfortable picture, where civilizations generally survive and grow and do interesting things, and where we are nonetheless real, requires something nobody has been able to supply. And the frightening option is not the one everybody talks about. It was never the third. It was always the first. If you carry one habit out of tonight, rather than one conclusion, make it the one about assumptions. Every dramatic claim in this area survives on something placed early and never examined again. That a recreated mind experiences anything, that anybody would build a grid the way we build one, that the universe is the kind of system a theorem about arithmetic applies to, that anybody who lasts becomes visible. None of those is unreasonable. All of them are load-bearing, and once you start looking for the load-bearing assumption, you will find it in about 2 minutes. in almost every argument of this shape, including every one I have made tonight, that habit is worth more than any answer, because the answers keep changing and the habit keeps working. There is a second one, smaller, and it applies to the coverage rather than the arguments. When something is reported as proved, the useful question is what had to be assumed. When something is reported as a breakthrough, the useful question is who disagrees and where they published. The 2025 papers were reported as settling this. A commentary arrived in 2026. Neither of those facts made a headline together. So come back to where this started. The popular version says we might not be real. The actual argument says something harder, that either we are not real, or almost nothing survives this stretch, or every survivor makes the same choice forever. You are inside one of those three. There is no way to find out which from here, and it changes nothing about tomorrow. What it does change is what you are entitled to assume. The idea that things generally work out, that civilizations last, that this century is a stage on the way to somewhere, is not a neutral default. It is a position, it has a cost, and the cost is that you have to give up something else to hold it. There is one more thing worth leaving you with, and it is smaller than everything else tonight. Whatever the answer is, you are the one who got to hear the question. For almost the whole history of this species, nobody could have followed any of this. Not because people were less capable, but because the pieces did not exist. There was no counting argument, no theorem about the limits of formal systems, no measured spectrum of cosmic rays, no way to know that other galaxies were even there. All of that arrived inside a single century, most of it inside a single lifetime, and it arrived in time for you to be told about it while lying in the dark. Whether any of it is running on something else does not change that it reached you. Thank you for staying with me tonight, or for leaving it on while you slept. Either one is fine. If you want another, subscribe and it'll be here. Somewhere on a plain in Argentina, 1,600 tanks of water are sitting in the dark, waiting for a particle that may not arrive this year or this decade, carrying a pattern that would answer all of it. Several of the ordinary ones have gone through you since this sentence started. Nothing has arrived yet. Good night.